Hello everyone. In this first Matterless video, I kind of want to give you a little bit of a rationale behind the project. Why I think this is interesting and what kind of is it and why are we building this? So the context is serverless programming, right? Serverless is kind of hot right now. There's like everybody's trying to get on this topic. AWS, of course, kind of started this with Lambda. But whether you go to AWS or you go to Google Cloud or you go to Azure, like everybody's talking about it, right? Like serverless functions, event-driven architectures, and all this type of thing, right? And there's a lot of good reasons for this. So let me kind of start this with kind of giving my kind of overview of where I kind of see the core of the whole serverless revolution, if you will. At the center of it is kind of like events, right? Certain things happen in the world and we want to respond to it. And rather than like building a process that is kind of running, that you have to run in a container or a VM or something like that, what we will do is have it trigger functions. So at the center here are events. Events happen. And when certain events happen, we either like queue them up in a queue to be processed later, or we invoke a function. And these functions, and this is what AWS Lambda kind of brought to the table, is like are just like event coming in, perform some logic, do something as a result. That could be triggering another event, it could be storing something in a data store, it could be queuing something, it could be calling an API. And the beautiful thing about the function is that they're kind of stateless. They run in some environment, and honestly, we don't really care. And they can run at any scale. And like a lot of emphasis is actually put on the scaling part, right? Like you could handle anywhere between 0 events per day and scale up to like thousands events or thousands of requests per second. And you don't have to worry about it. You don't have to worry about building infrastructure for this. You don't have to worry about clusters. You don't have to worry about scaling policies. Somehow the cloud, like the serverless cloud, is handling this for you. That's kind of where a lot of the emphasis is put and the value is seen. I've been working in this type of environment for some time, and definitely the scaling aspect is great because indeed you pay for what you use, right? But I also find this whole programming model, like even leaving out the whole scaling aspect of it, very interesting. It kind of pushes you, it forces you to have a very clean separation of concerns, right? Events, queues, functions that do a little thing. And we are really also, from a technical perspective, encouraged to write small functions because they run quickly, they boot up quickly, and they are really like, targeted at performing one small task quickly. And where kind of like Matterless comes from is like, hey, this idea, even if you don't care about like cloud scale, if you don't want to build the next whatever, Snapchat or whatever, even if you want to do very basic things like IoT things, or you want to create a chatbot or something that really wouldn't require, like thousands of like invocations per second, it's still interesting to kind of take this programming model and use it. So why, if this exists in the cloud already, why would you want to look at something even at something smaller? Well, you may be a kind of an enthusiast and say, well, I want to host all my stuff myself. And it's like, I don't know. I like this as a hobby. It may be I have a Raspberry Pi, and it's like sitting in the closet and it's not doing anything, and I kind of want to use this in a useful way. So maybe I can run these types of applications on that. Or you may have like requirements around, like very high security requirements, and you're not comfortable even pushing stuff into the cloud, or you want to have very tight control over where your logic lives, where your data lives, and so on. There's various reasons why you want to do this. Or you're kind of like afraid of like the Googles and the Amazons, and you kind of say, I give me control over this stuff myself. Or, and this is a little bit of a nasty thing, but you feel you're not in control of the cost because like also you pay for what you use, and like if you don't put the right constraints in place, it may happen. And there's always stories about like somebody who accidentally like DOS themselves or get a lot of traffic, and now they have to pay huge credit card bills, and like how could that possibly happen? Or the reason may be, like I've been doing serverless, it's really cool, but what's next? So that'd be another reason to kind of be interested in Matterless. So introducing Matterless. Matterless, the tagline for now is putting serverless on your server, which of course is like a bit tongue-in-cheek, right? The idea is, okay, if you have a use case, and there's various things that we can talk about, like basically small things, small scale use cases like IoT, like creating a chatbot, like doing one-off things like pulling some data from GitHub every day and then posting something on a channel. It could be anything kind of random. That doesn't require cloud scale, right? And also, even if I want to self-host something like serverless, there are solutions like that. They generally like build things like OpenWhisk, OpenFast, rely on Kubernetes. So you have to deploy a Kubernetes cluster on your own machines or something like that. There's a lot of hassle, right? Matterless basically wants to reduce friction and allow you to build serverless style applications for small scale, very, very easy and quick. All right, so this is a kind of an architecture diagram of what Matterless contains right now. So again, serverless. At the core are events, right? So there's an event bus. And when events trigger, basically the only thing you can do right now is trigger a function. So a function will be invoked. At a technical level, these functions right now, but I think we can expand this fairly easily, are written in JavaScript. They run on Deno. And Deno, sorry, is the kind of like, you could look at it as kind of the successor to Node.js, right? The same people that build Node.js, Ryan Dahl and friends, let's say, they now build Deno, which is a runtime that is much more secure. So actually we can use this as kind of a sandboxed environment. And that's how it's used in Matterless as well. The functions that run in this environment don't get access to the disk. They get limited access to network. So we're kind of constraining them quite tightly, right? So it's fairly safe to run arbitrary code this way. But potentially it's easy to expand this. And actually I have this working with like Docker containers as well. We could write functions in Python, in Go, and like kind of run them in Docker containers as well, right? So events trigger functions, and functions can do honestly whatever you can do in a Deno or a Docker container process. There's huge numbers of APIs. You can call GitHub APIs. You can store data in Dynamo or DB if you want to do something like that. But Matterless also comes with a simple key value level DB based data store. So if you just want to store simple amounts of data, or actually it's probably quite, it can grow quite quick if you want, you can store some data locally inside the app as well. Then the question is, okay, so events occur, they trigger functions, and you could do honestly whatever you want, right, inside of a function. How do we get events in? How do we get things to respond to? Of course, functions can trigger events, so functions can trigger other events which may spawn other functions, right? But generally, we kind of want to respond to the outside world, right? I work for Mattermost, so we may want to respond to like bots receiving messages. We have a focal board, like cards being moved around. But also, if you use Jira, like I don't know, if a ticket is created or changes status, maybe you want to be notified about that and do something custom. GitHub, new issues are created, pull requests are created, Confluence, IoT, maybe my Raspberry Pi is getting above like a certain like heat and I want to be notified about that. Zapier, Opsgenie, AWS, honestly, there's all kinds of different sources of events that we would be interested in. And there's different ways of getting these events into the Matterless event bus. One of them is the HTTP gateway. So it comes with an HTTP gateway built in. And there's an API to create an event. So that's the most basic thing. You can very easily, and I'll show you this in like future videos, create custom HTTP endpoints. So an external system will call an endpoint, a get, a post, or a put request, or something like that, and that through a function is then translated into an event, and now it's inside of the Matterless ecosystem, let's say. The other thing we have here is jobs, and jobs are, whereas functions are always short running, right? They run for a couple of like a minute or so, like a couple of seconds, maybe even like milliseconds. Jobs are kind of the long running version of this. They boot up when your application starts up and they keep running until the end. Their job generally is, is to poll for things. So if you don't have like actively data being pushed into your Matterless instance, you can ask for it. So for instance, every minute, ask a GitHub API, hey, what are the events that occurred here? I'll take the ones I care about and I post them into event. Or in the case of Mattermost, I'm going to listen on the WebSocket. I'm going to like authenticate myself. I'm going to listen to all the events that are incoming, and I'm going to publish those events, the ones that I care about, as events. Then there's an abstraction and mechanism on top of these to kind of like make this much more user friendly, and kind of like we can create abstractions on this. So you can like basically say, I want to have a Mattermost listener, I want to have a GitHub listener, I want to have a Zapier listener. All these listeners you can build as macros inside of Matterless, and we'll show it. I'll show you demos of this. But that's kind of how we get different types of events into the system. All of this is orchestrated through Matterless definition files, MD, which of course is also Markdown. So actually these files and basically your whole application you define in a Markdown file with a certain format, which I'll show you. Basically you hand Matterless one or more like Matterless definition files and it will just run it. So from a deployment perspective, what does Matterless look like? It's very simple. It's a single binary. So you don't, and it has basically zero dependencies. It will download Dino on the fly with the first time you boot it, basically. So you don't even have to have Dino installed. There's no configuration required. You can just type MLS, enter, and it will boot up, right? You don't need Docker, you don't need Kubernetes. This runs on a Raspberry Pi, it runs on my Mac, it runs on, honestly, whatever you want, right? It's written in Go, it's lightweight. And you can spin it up, and I'll also demo this as I kind of show you how to actually use it to respond to when your Markdown, your Mattermost definition files, have changed, and it basically reload as you save. And you'll see that like sub-second, you get new versions of your application. So the deployment cycle is actually very, very fast. All right. This is extremely experimental, right? This project is very experimental. We're kind of like interested to kind of see, like, are people interested in this? We are using it internally for various things, so we're kind of excited about it. But this may change a lot. And actually, like in the history of this project, like a lot of things have changed over time, so it will probably evolve more in the future, but we're already very interested in your feedback. Okay, that's it for this introduction. Next up, I will start to kind of show you code examples and see kind of like a 101 type course of like how to use this system.